Morning, Vikas.
Hi, David. How are you?
Pretty good. How about yourself?
Good.
Well, after juice.
Hey, David. Hey, Vikas.
Hey, hello. Sorry,
Hi, Pritesh.
can you hear me?
Yes,
Yeah.
yes, we can.
Okay, let's give everybody a minute or so. See who else will join, and then we'll proceed. By the way, how is the background noise from my side? Is it you guys hear a lot or nothing?
Not
I hear
much.
nothing.
Okay, good. I'm in a little bit of a noisy place.
Mhm.
How about
Hey, David, Vikas, Pratyush.
Hey, Bala. So while we wait, just a question for Vikas. It's okay if it's okay, David.
absolutely? Go ahead.
Yeah, Vikas. So we have this. Do you want to talk about NGMM here, or we
Yeah,
should do it
sure.
after the-
Yeah. No,
Yeah.
I can talk anything that is we cannot talk. I'll let you know.
I see. I see. Yeah. So, have you decided to officially support the OCP JEDEC standard? It's
No, we do not have any official standing before actually we see at least one test case.
okay. I see.
Yeah, yeah.
I see.
So, but what I have done is that I'm putting it everywhere that
Mhm.
we are going to follow OCP and 3D blocks
Mhm.
for now. Now,
Okay.
because I think we have seen many times over that there are things in 3D blocks that are like MDK and material and all that. That's not even part of 3D blocks yet. And I
True.
think today's meeting we know, right? I mean, nor they have any plan. So to complete any assembly design KTDK, we have to have both, right? Materials and electrical
Mhm.
and structural and for reliability. So that's why. But like, and you can educate me when we take an official stand. Like, what do we need to do?
Hmm. Yeah.
Like, are there any steps that okay we are officially supporting or not supporting something like that?
I guess it'll have to be announced through the EDA working group within the team, right?
Okay.
Yeah. Yeah. I mean, it's a separate from here discussion, but it's good to hear that at least it's driven by a test case. So as soon as you have a test case,
Yeah.
you will. Yeah. Yeah.
Yes.
And have you been able to get that from us at all? Or
No, not really. I actually sent an email to Tony
okay.
again.
So
Yeah.
I may have let me see. March 12th, I had shared something with Andrew Kang, and if that will meet your need, but we can get started here. We can. I'll send something to you offline.
Okay. Okay. Sounds good.
Yeah. Yeah.
Thank you.
Sorry, David, we took your time.
Oh, no problem at all. No problem at all. This is a relevant discussion. Okay. We have a new person that has joined us for today's meeting. Would you mind introducing yourself? Do you go by David or?
Oh, sorry, sir. My name is David Wee. I was thinking what was this meeting about because this is my first time uh, in the OCP. So I actually received this calendar. I was trying to find out what is this meeting all about, whether I was in the correct group or not.
Yeah, I can give you a quick introduction to CDX. So CDX stands for Chiplet Design Exchange. And we focus on two items in our charter. One is format development for exchanging data for chiplets. One of the work that we have done, some of the work that we have done, it's related to CDXML, and that's adopted by Jack 30. So our group kind of feeds our work into JEDEC to become an official standard. And the second part of our charter is workflows for integrating chiplets, right? What steps are needed and so on. And that kind of helps support any format development, right? Both are are tightly coupled. So that's what we do. What is your interest in chiplets? Do you have any interest in chiplets? Do you represent any company that's looking into chiplets?
Oh, okay. So basically, I'm more interested on the link as well as the physical layer for the implementation of the chiplet in the design. So I was trying to get more information with that. Before that, I was attending the link layer meeting, and I saw this calendar, so I was thinking,
Okay.
yeah, what was this about? And I'm actually quite new to this OCP. That's why I'm trying to attend. So you all can carry on, maybe just listen. If I'm
Yeah.
not at the correct group, then I will exit the meeting.
Yeah, you're welcome to stay as well.
Yeah.
Do you represent any company?
Yeah, I'm actually working for Infineon.
Oh, Infineon. Okay. Yeah. We don't do much work with regards to the physical layer and BOL5. We only actually right now are trying to add stuff to the JEP30 that will cover CDXML and JEP30 that will cover some of the SIFTI requirements for die-to-die files. But today's meeting specifically, we're going to be focusing on test.
Okay.
We alternate SIPI and test every other week.
Okay, thank you. Thank you for the
Yeah, sure. Okay.
Yeah. Hey, David, this is Bala. So maybe we can recap what we discussed in the last meeting, and then
Yes.
start from there, to get the feedback, because we were not able to time for the feedback from the peoples last week.
Yes.
And
Let's do that.
so yeah, me and Pratyush, we did some brainstorming with Tony on the same set, and so we have some info from Tony and the expectations from Tony, so we can go through that as well. Yeah, so this is the recap of like what we discussed last time, yeah, 2 week before, where we gone over this. Okay, give me a second. Yeah, so we did gone over the 1838 architecture block diagram with highlighting this all the test interfaces across the chiplets and across the partitions, and down all the way down to the DFT codes. So which are like a PTAP, STAP for the inter-die connectivity, and then there is a SSN fabric for the scan connectivities across the chiplets. And so then downstream from the PTAP, we have the connectivity to the SIP interconnects across to connect to the EDT, OCC, and SSH. So and memory based and boundary scan and so on and so forth, right? So for all the
Yes.
DFT codes are initiated through the PTAP for the test access, and then PTAP is also used to consume the results, to read back the status, things like that, and so and then we also touched upon the boundary scan, which goes across the functional IOs. Those are the blue boxes, where so we have a functional IOs, and then there are JTAG IOs which are connecting the to the package side, and then and then there are SSN IOs for the scan tests.
Okay. About quick question. Sorry to interrupt. IEEE 1500. What is which part is that? You mentioned scan, and it's obviously not JTAG. When you talked about PTAP, which
right.
of these
So,
apply to?
yeah, I did this color coding where you speak. So your question is mainly on the 1149.1.
Actually, 1500. IEEE 1500. What is the?
So 1687, 1500, or I don't know what is 1600 here.
Yeah, 1500. Yeah, right.
Yeah,
IEEE.
1687 is the IJTAG plumbing for the automation side. And then there is a IEEE 1500, it's 15. So 15 is a protocol standard which which is the hardware stack, which is interfacing between the IJTAG, between the PATAP and the SIP network.
Okay, let me ask you in a little bit narrower context. So HBM3 has IEEE 1500 ports. How are those used today?
Yes, actually, that is one another topic where people are really going. There is a long debate happening between the different test communities, where because a few people, they don't like to utilize the tap controllers. They wanted to stay with the IEEE 1500 controller, and even for the die boundaries, right? So they want to eliminate one layer of like a serialization, and leverage some more like a faster interface with the 1500, which is still serial for the data access, but then there are more control signals, so you don't have to go through the long the tap sequences to interleave between the register access, right? So there is a small benefit for the test time. So, but in this diagram, I'm not showing that the IEEE 1500 is utilized across the die to die. So I have limited myself at the tap level.
Okay, so today HBM3 is it? What is the expectation, right, for dies for chip? Actually, I don't even know what to call this. Basically, systems, chiplet systems that use HBM3, and HBM3 comes with a 1500 ports, right? IEEE 1500 ports. Are those ports expected to be exported at the package level, or are those ports connected to the ASIC, and then ASIC, basically all the testing of the HBM happens to the ASIC?
Okay, so so the answer is yes and no. Like you will have like for the wafer test, you will need that access, right?
Yes.
Even for any debug, like so they might have that the access through the sacrificial pads, things like that. So but in the final protection, which will go under the hood to integrate into the actual compute die kind of clusters, right, into the ASICs, the logic dice portion of it.
Okay, so in the final assembled product, you're saying that the HBM at IEEE 1500 ports are going to be connected to the to the
The la-
ASIC, and then all the testing happens to the ASIC.
Right. Because the I haven't seen. I think there is only one presentation I have seen. The HBM dies were in the as a bottom die for the 3D stack. But majority, like I see that the logic dice were or the even or the like IO dice are in the as a base die. Right, so it may be different based on the application need. Like if they need a performance driven and which is high speed IO, so the high speed IO die will be is a bottom die.
Okay, and that bottom die then would be responsible for. It will have its own controller that will figure out what to do with the HBM.
Right. Yeah.
Okay.
Yeah, because only the bottom die has access to the package pads. Right, so the package pads is directly connected to the bottom die.
So I was looking through HBM the other day, and that's why I'm talking about the IEEE 1500 ports. The thought I had is, say somebody wants to put HBMs on his interposer or substrate or whatever it is. Is there what is needed today to make that integration happen? Are there any challenges there?
Yeah,
basically, I'm thinking of HBM as a kind of pilot test case to see what additional data do we need in CDX and Algebra 30
right.
to enable the integration, right? Because you know, HBM3 is a ready chiplet, ready to go, right?
Yeah,
What do you
that
think?
is true. Actually, I believe this is a problem statement to solve for the folks who is driving the IEEE 1838. So right now, I'm not sure like what is the recommendation from the IEEE 1838, which is primarily like a PTAP STAP kind of environment from the package access standpoint, or it can be even go to this 1500, right? So we don't know what is the priority call that they are making it there. So I believe like we should, as from the CDX standpoint, I think if we restrict ourselves to the 1838, so that is good enough, I believe.
Okay. And okay.
Yes, so far IEEE 1838 is the only commercially available spec for these 3D DFT, right? 3D DFT integration. So if people are adding the layer, maybe I can take an action item and go through that spec, and we can brainstorm next on the next session.
Yeah. Tell me again about the difference between 1838 and 1500.
Sorry, I missed your question. Can you repeat that?
What is the difference between 1838 and 1500?
Okay, so 1838 is a composite of like 1149.1 and the 1500, right? So the 11 like 1500 has maybe I can make some classification diagram and then share it to you. It is easier to follow, like where you see the IJ tag and then there is a parallel bus, right? So these two together creates that 1838 wrapper.
Okay.
Right.
So,
but now what you're saying is like a 1500 comes under below like after the tap, right? So that this chopped interface between the tap and the SIP network, the serial network is 1500. So that if you eliminate the PTAP integration, so you and then bring out this intermediate control interface controls to the package, that becomes like a 1500 combination with a it's going to be only 1500, like there's no 1838 in that scenario.
Okay, got it. So, okay, got it. Okay, now
Yeah.
I'm slowly getting it. Okay.
Yeah, it's my bad actually. Maybe I should have put that 1500 list of signals and for compare points. So I think that's a nice feedback. Like I can add that, so to make it complete.
So you're saying that is it typical for somebody to drive the 1500 directly from the package pins, or not really? 1500 is used only for wafer probing.
No, it is not difficult. Right now, if you are compared to the 1149.1, so you have a more audience to support where for DFD kind of environment, like you have trace debugger kind of things, and so everything is IJTAC based, like JTAC based,
Okay.
right? And so even this 1687 is IJTAC based, like so like there are a host of wrapper around the 1500 and as a control through the parent interface through the tap interface mechanisms. So that's where this is a known problem area. Like so the when I was talking to Tesson team, they also mentioned about it. Like some people are doing that, and some people are originally when they went with the 3D DFT, like if across all the major three DFT EDA folks, everybody had a common methodology proposal, like a PTA stuff kind of net, like a tap level interface to start with. That's a scenario even at the chiplet level also. There is a tap controller. This is the primary serial programming interface. But the 1500 was serial interface at the partition level, like in each individual partitions, where because you cannot throw like a tap controller everywhere, and so that makes the software life or the test programming side is really complicated, and so they limited all the partition methodology is like IEEE 1500 control. Like now they are expanding the scope where so the chiplets are becoming like a kind of partitions for the package, right? For the SIP activities. So
Okay.
so in that regards, like they are kind of like a bottom-up methodology. They are trying to infuse this IEEE 1500 utilizations at the chiplet layer as well.
Okay. Do you
Right.
know what is the roadmap for HBM? Whether HBM4 has changed its test ports to different protocol, or whether they plan to change it in the future?
So HBM, what I have seen with the Snug presentation last year, they plan to replace their own parallel HBM interface with the UCIe. Right, so UCIe is going to be becoming like the primary interface, like a similar thing like a DDR, for example. So DDR
Yes.
has all the command register access through the DDR parallel interface itself. Like there is no dedicated tap controller kind of stuff. Like maybe the DDR controller will have that, but then actually the DRAM itself, it is parallel access is derived from the DDR protocol by itself.
Oh, interesting.
Right.
Interesting,
So that way, yeah. So the UCIe, like I think UCIe will be the final access mechanism for the HBM as well.
Oh, interesting. Do you know would that be usually 3D or even 2.5? What is it? Advanced package usually.
No, I don't know. Like maybe you can share the contacts so we can discuss with
Okay.
them.
Yeah, that's interesting because one of the challenges today is usually it can go faster, but it's limited in reach, right?
Right.
But if it's usually 3D, that's a different story.
Right. Yeah. Now they are also talking about the area efficient UCIe, like a smaller UCIe versions, right? So we need to find out does it backward compatible to the spec or not.
Oh yeah. Okay.
Yeah. So yes, it's the same debate like where even the PCIe communities, so they cannot support the spec like the latest PCIe like 5 or 6. It's not not compatible with the PCIe the earlier PCIe like 3 or 4, right?
Yeah.
Yeah.
Yes. Okay. Cool. Yeah. Thank you for the clarification. Yeah, might
Yeah.
be interesting to see. Uh, uh, Going back to my original thought is integration of HBM into a test scheme, right? What is there and what is needed. That's
Right.
the idea of informing us. Does what data we need to add for HBM to enable seamless integration, right? I'm sure somebody can code the ports and mark them as 1500 and do the necessary. The question is, since there's only few HBM vendors, that might be easier to
Yeah.
handle, the updates. Plus, JEDEC, apparently they will standardize on shipping. Instead of shipping a spreadsheet with the bump map, they'll be developing actual JEP30 files. So this should be ready to integrate into any flow.
Right. So HVM integration actually doesn't also supports that the HVM DFT integration either through the tap controller or through the IEEE 1500. But it is not methodologically aligned to support the 1838. That's what the delta is like. So there is a minor deviation, but people are doing it because of the lack of time, or they are not having the capabilities to do this all this PTAP STAP kind of infrastructure inside the HBM layer, right?
Yeah.
So and so people make the shortcuts to prove the concept where for the HBM for the test accessibility. So like IEEE 1500, people are going with that. So yeah, let's consolidate that information based on the 1838 spec.
Yeah. Okay. Yeah, it sounds good. It might be also interesting for the vendors to see if they have any shortcomings in their data or their implementation, for the vendors to see that, hey, we have an automated flow to do the test integration, but you guys need to make change ABC. That might be easier, all right? And take that to JEDEC and see if all parties will agree.
Right. So yeah, what I'm thinking is mostly they might have some secondary access to the entry point to the SIP network through the like an intermediate 1500 controller, like a PTAP tap controller, and then there's going to be a mini 1500 controller, so you can drive through the tap or the 1500 controller, like so that way. So the at the end of the day, it's giving an access to a number of serial access ports.
Yeah.
Right. So and then
Yeah,
it will be get internally multiplexed, and you can choose to select like which one is more appropriate for your integration.
yeah. Let me ask you a different kind of question.
Yeah.
If the ASIC is driving or if the PTAP is in the ASIC and it's driving the 1500 ports of the HBM, does that open a security vulnerability into the whole system?
So taps, like, okay, for the DFT does not handle the security, right? But the security handles the DFT, like where they add the few kind of overrides for the tap access eventually, like when it goes outside the manufacturing or assembly. So they blow the fuses.
Okay, so fuses get blown and you can no
You cannot.
longer access PTAP in any possible way.
Right. So that's the same scenario even in the
Yes.
2D like scenario also.
Okay, that's good to know.
Yeah.
All right.
So now the problem areas to sort out is the main bottlenecks are the creating this library views for the complex pads, even GPUs kind of scenarios also. So that is something I'm planning to work with the Tesson team and to find out what's the consensus and how do we proceed. So with the TSMC symposium, when I approached a couple of third-party vendors who are supplying these IOs, so I received some kind of a positive answers where because they have the regression systems and for the to characterize the pads in their automations, and so they know everything what we need for the DFT insertion and automation, and so it is easier to extract from their assistants, and so they have an automation solutions to extract what we need, like what the different default values and for the pins, and how do we control when we are in the test mode, things like that. So creating that is doable, and that's a mechanism that they are also using it for their data sheet documentations currently. So writing that information automatable in an automated way to print something DFT insertion tool needs, like a equal format kind of thing. It's doable. That's what they are saying it. But we need to assess the risk, like if there is a if all possible scenarios are covered, or like maybe we can reach like a 60 to 70% automation on that area, right? To make that everything is streamlined to the standards. So there are some risks where some custom IOs people adds like 50s and 60s of control registers for various feature controls in the IOs, like Intel, for example. So those type of complex cases will be like mode-based controls, and which will be more tedious to automate through the equal. But we need to derive what is the test mode scenario, and then just to take that controls alone.
Okay.
Yeah, so those things I'm working out. Like probably I like to add some more details on that. I'm planning to do like in another 1 or 2 weeks to complete this effort. And so then based on your feedback and the team's feedback, like we can also add incremental data on that.
So out of this list, where do you think CDX can help out?
Yeah, so Tony had asked us like to join the other DFT group where people are driving this chiplet test spec, like Rajesh and people are involved in that with Mike is driving that meeting. Like, so I plan to join that meeting. Like yesterday I supposed to join, but I got into this one urgent training. So I wouldn't go there. So I want to walk through them, and then Tony wanted some consensus and feedbacks addressed from that team, and so then we can make a call. That's what Tony is expecting now. And I found their spec also, like there is no overlap with what we are doing it here with their efforts. So they are mostly they are going with a concept kind of paper where they are discussing about different scenarios like thermal and the test access and the challenges and the different IOs, things like that. But they haven't gone to any concrete action list kind of things in that flow yet. So we can see like how we can collaborate with that team.
Yeah. Yeah. Okay. Yeah. Yeah. There seems to be quite a bit of slow work here that needs to be ironed out before any we can decide what do we need in CDX or not to support it. Right?
Yes, yeah, I think that is a big call. Like, so we need Tony in our conversation.
Yeah.
So yeah, first thing that he liked this the presentation and all the details that produced here, and
Yeah.
but he wants to see the other team's feedbacks is covered, and to make it to more consolidated. And so probably he might think he might come back and tell us, okay, I want to cover this, and I don't want to get into that kind of things.
Yeah.
So yeah, so let's see. Like so, let's have one more discussion with the other team, and have like one or two discussion with them, like to go through that, give this information to them, and get their feedback, and like then we can come up with a priority list, like what is more appropriate for the CDX to do.
Yeah. Okay. Yeah, sounds good. Do you know when the meetings are for the testing?
Yeah, I think it is 8 a.m. Wednesday. I'm not sure it is weekly or bi-weekly. I can share the contacts, and then we can ask them like when is the interception session we can have.
Let's see. Do you know if their meetings on the calendar?
Yes, I can forward that. I have it with me. Yeah.
Um,
So it is
wait,
there 8 a.m. yesterday. It was there.
I
This
had
one,
I had
SIP,
the link to this.
SIP test to this one. Let me.
I was thinking about the OCP calendar, whether okay, there it is.
Yeah.
Let's see. And where's I don't see it in the calendar. Do you know if they have a group link?
1 second. So I can see. So these are the people there. There, Mike.
Yeah.
Mike Bartley. He's the guy who is
Okay.
driving it. And then Srikanta, I don't know whether he attends it. He's an options guy. And Rajesh, or OCP
Yeah.
plus
Yes.
now he's in
Yeah.
Cadence.
Yes.
And couple of folks from Intel. And,
Okay. Yeah, let
yeah.
me find out. I'll email these guys and ask them what the setup is and if they have a group CEO link and calendar entry and things like that.
Yeah.
Might be useful for me to stop by and see what you guys are talking
Right.
and
Right.
see what I can plunder from the team to bring to CDX.
Right. Right. Yeah.
Yeah. Yes. Yeah, these guys are slow guys. Yeah, let's see. I don't know the other people. If they're automation people, there may be some common ground to add properties and tags to the CDXML pins to inform the automation what is going on.
Mm-hmm.
Yeah. Okay. All right. I will.
Yes, David. I was shared
Yes.
the
Thank
calendar
you.
invite and the email. Yeah.
Yeah.
Yeah. Let's try to join that meeting on Wednesday next week. So you can also reach out to Mike, or maybe officially can add you on the meeting.
Okay. Yeah. I think that would be awesome.
Yeah.
I'll take a look at the invite and add
Mhm.
myself. All right.
So, Pratyush, because Boone, like, you have any questions, and do you have any thoughts, like what we should do?
Though not right now. Our conversation. Let me get to this in next couple of weeks, because 1838 is kind of like the benchmark for for the DFT. The rest, everything, like you said, and how we are going to access, that's another. And the key, another thing is like repair techniques. That is actually in still in works. So not sure about that part also. Because remember, we are not talking about repairs and all that, like through testing. So that is something also we need to take a look at.
Right. So I will repair or redundancy. Like so I think uh, I need to look at that the spec for the UCAE, like for the repair and redundancy. Are they talking about uh, like how do they control it, right? So at the end of the day, I believe it's going to be the fuse interfaces, right? And so most of the fuse interfaces are achieved through this the biset chains, and it eventually comes through the tap controllers, right? So
Yeah.
like memory repair versus IO repair, it's one and the same, like from the fuse and the tap access standpoint. Yes, I believe like 1838 the
1838 is just like, testing point of view,
right.
like how to give access to individual chiplet. But there are few things that even I don't know, or I have to read in details, like how exactly you can monitor, like when you actually go in a debug mode and want to read out the debug register, how is it going to work? That part also is not very clear to me. Not sure about that.
um yeah
Like
yeah so
pass fail and debug register reading and figuring out like what's the issue. Like debug is also very important, because not every part we can send it to FAFI.
mhm,
It's an expensive business. So
right. Yeah, so those things are will be covered through that IO based controller, right? Whichever the best mechanism that they are going to do, and so that controller will have all those care bits defined. So I don't I'm not sure whether at the CDX level, Vikas, or do we need to consider get concerned about um, the BIS strategy kind of thing? Like
no,
I
not
think if we
not really at this level. Only
Mhm.
thing is, like we need to be aware of it. See, we don't have to
But-
address it, but see,
uh-huh.
we come up with something that doesn't provide the critical testing aspects. Then it's like a half solution. Like I said, everything doesn't fall in this scenario. Only thing is
Mhm.
we need to be aware of it. That's it.
Right, right. Okay, got it. So you're saying that at the in for the concept specification perspective, like we need to address like the at least the some scenarios about it, right? So
Yeah,
where for the people who are reading it, so and so they can consider these are the features and these are the test plans,
correct.
and
Yeah.
so
Yeah.
yeah, so what are the test cases to expect and
Something
all
is
those things.
something a realistic one. Like,
Right,
okay, this is how from end to end it works in the production.
right,
Okay, now we don't have to know everything, but as long as, okay, this is the hook or something, then it's a good solution.
right. Yeah,
Yeah,
that part I agree. Like yeah. So now yeah, that I'm thinking like now the fuse controllers, like how it is going to be shared, the fuse allocations,
yeah,
right? For example, HBM and these type of
correct.
UCIe, IOs, right?
Yeah,
Like, so all
yeah,
those things where
yeah,
whether each chiplet will have its own fuse controllers, and
correct.
so what's
Yeah.
the mechanism to optimize the fuses, and can we do shared fuses across the chiplets?
Exactly. See,
Right,
like right now, okay, we have to do redundancy. People put muxes over there, but where is the information is stored? How
right,
we actually inform that, okay, you have to replace this mux. So suppose like top chip actually changes its fuses. Now, how does the bottom chip know? So they have to talk to each other. Simple things like that.
right. Yeah, yeah. So and that also calls for like where do you physically locate this hardware, and then how the EDA tools are supporting those abstractions, right?
Yeah.
So right now there is no EDA capabilities for the shared fuse access mechanism across the chiplets,
Right.
right? So all the
See, the thing is like, see, somebody sends a chiplet, okay, like we are OSAT, right? OSAT type. So two chiplets, yeah, fuse it. But there has to be a requirement for it. Like your chiplet needs to have all these things before even we go, like a feasibility kind of a thing.
right,
So
right.
so that's that part. And then
Yes.
we prove it. So
Yeah. Now I hear you more. Like, yeah, what is the actual problem statement that you want to solve with?
yeah. And like
Now,
I said, we don't have to know everything. Only thing is we should be aware of it. That's all.
Got it. Yes. Right.
I have a question and one idea. So, on the question, Bala, you mentioned that fuses are blown. Would they be blown after wafer test, or would they be blown after final test?
So the manufacturer, like for any repair kind of fuses, like a memory redundancy, like for example, you run the memory based test. In the wafer test, you find some bits are not operating, and then you have a chance to repair it. So those fuses are blown at the wafer test itself, and the cases at the shown up in the manufacture, like a final test, where yes, the hot temperature and low voltage kind of testing is done at the final test, right? Because the wafer test, and they distribute the wafer testing and the final testing with respect to the different temperature and the low voltage and high voltage selections based on the plus or minus 3 sigma.
So Bala, in
Yes.
summary, in
Mhm.
short, if we have to provision for a multi-die, both fuse blowout, we have to assume that it may happen at the wafer sort, or it will only be possible at the package level in a 3D hybrid bond example,
Wherever
right?
it's caught.
Because there
Wherever,
is no wafer sort, so fuse blow
No.
will probably happen.
Mhm.
Worst case I'm talking about. If you can do,
Mhm.
and so let's assume the problem statement that
Mhm.
you have to blow the fuse of one die through another die. That's
Mhm.
the worst case example, right? In a stack configuration.
Right.
Uh, yeah. Question then: can the ASIC, if the fuses get blown, such that the pickup controller is not accessible anymore, does
No,
the
no, no,
rest of
no, 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 no. Those are secure fuses. Like secure fuses are done final. Like when it exits from the assembly, that's where the security flows. Fuses are blown. What we
okay?
are talking about this yield related fuses, which
Okay.
are yeah.
Yeah, I was thinking about the security fuses.
Yeah, yeah.
Does
No, yeah,
that
yeah.
can the ASIC firmware tell if that pickup controller has been disabled or not?
Um,
Which
so,
controller? Sorry.
for the PIT,
Oh, PTAP. Okay.
PTAP, yeah. So yeah, there will be a. So what was your question? I missed that, David.
Basically, if I have an ASIC and I load the firmware in that
Uh-huh.
ASIC, can that firmware tell whether the pickup controller is accessible or not?
The firmware, I don't know if they give all this fuse related information to the firmware, like where how many what fuses are utilized for what access, right? So that is again a security damage, right? So they don't I
so
don't
these,
think
the tap or fuses can only be accessed through tap, and tap has a key, the security
right.
key.
Yeah.
Until you have that, you cannot read out fuses.
Okay, so
Um,
that's the tap security key. It comes in two places. Like to Vikas pointed out one place, and then there is one more fuse where one more signature where it can unlock the tab. the PTAP fuse, right? It can override that PTAP fuse and in a factory setting, like so you can give a life to the PTAP access again. So that will be useful for any of your RMA kind of debug, right? But now for the in-field test scenarios, so this is again a challenging part where customers like the end users when they want to run the DFT test. So, but no, I'm confusing myself. So that time they don't go to the PTAP, like it is only for the ATE purpose. So it will be used inside through the firmware and then some flash memory, and through the CPU it will go to this SIP network.
Yeah,
So
I was thinking when talking about in-field use, I wasn't thinking necessarily somebody running DFT. I was thinking of for nefarious reasons. If you you have a supply chain attack where you take the parts just before the final security fuses are blown. Now you would be able to access PTAP at any time, even without a key. And like my question is whether
right, yeah.
right, the mitigation for that would be the firmware that gets loaded and being able to tell if this had the security fuses blown and PTAP is not accessible, then the firmware would just refuse to start, right?
Right. You're right. Yeah.
Right. And then if there's a security key to unlock the PTAP, now a bad actor, if they obtain that security key, which they can, right?
Right.
They would be able to control the PTAP then, right?
Right. But those should be ideally it should be controlled through the security software part of the firmware, right? So these are the access mechanisms, and so the firmware will have that secure access code, and so those things will be eventually making sure that what is needed for the customer and what is not needed.
Okay. Yeah. And actually, okay. So the idea I had, I wanted to move to my next thought is, I think Pratyush mentioned about feasibility, right? Wouldn't it be if you are planning the whole test setup, right? Say you're developing an ASIC and you're getting a bunch of third-party chiplets. Even feasibility planning for your DFT, you would need to know what. It sounds like you need to know a lot about the chiplet, what's in them, right? Which have fuses, which don't have fuses, and things like that, right? That kind of information would be perfect to be put into CDX ML and Jet30, right? So that now you get the chiplets and you there's a machine readable description of what's in each chiplet and what possible flows. Right, from that you would be able to derive what do you need. Is that something that we can tackle?
Yes, actually, so Tony asked me for another test plan, and so that is stalled there in the initial discussion itself. Like, so I need to discuss with Tony like in detail. Also, Pratyush was there. Like, so we want to brainstorm more detail about like what exactly that we need. So that is more of a like a feature list versus AT test plan, and what do you need for the to achieve the test plan, and how it is covering the expected coverage, right? So like how much portion of the coverage is useful for the manufacturing test and how much is for the in-field test kind of differentiation, right? So there's a long list Tony is envisioned, and but what's the format that he is looking at, and how he wants to achieve that goal is I'm not fully clear on that. So I need some more session with Tony and Pratyush and to brainstorm and finalize that part.
Yeah, I think this is something that CDX can bridge that gap, right? As long as there's an idea about feasibility workflow, we can definitely support that feasibility workflow with data.
Right.
CDX and objectives, right? And it would be perfect if that data can automatically drop from the test instruction flows at the chiplet level. Right, so we don't have to have people going and clicking or editing XML files to add stuff, right? If this can automatically drop that to the person.
Right. Yeah, but having that machine readable and that's where we the CDX comes into play. Right?
Yes.
So
Yeah, exactly.
and how much we can go deep dive into the chips and what languages the CDXML has, how many levels of hierarchy that we can achieve it, and so yeah.
Oh, okay. Yeah, there's something that we can. As soon as there's a little bit more clarity, we can definitely work on it. Okay. So a couple of logistical items I wanted to cover for today. Now, Bala, you asked me about the recordings of the meeting. So the short answer is I don't know right now. There is there used to be some automation at OCP that every recording, the way the logistics were, every call gets recorded and goes into Zoom. But due to space limitation, after I believe a couple of weeks, 2-3 weeks, something like that, the recording will be deleted from there. So there used to be an automation, or at least a person who was doing that for us, where they will take that recording, copy it to OCP location and put a link on a wiki page. I looked around for that, and it seems like the last recordings were from late last year. So I think we may have lost a few recordings. So I was speaking to the OC leads to figure out how they're handling that. Right now, I don't know how to handle that. So give me a few days to figure it out.
Okay, no problem. Yeah, I was thinking that if I had that recording from last week, right? So I can forward that to the other test teams and like maybe ask them to go through it before we go to that the next sync with them, and so that they are prepared to know like what's the context that we are coming like, so we can save some time from the meeting.
Right. Yeah. Let me first find out what recordings are present right now. Still in the Zoom account.
Okay.
And once I figure that out, I may temporarily copy all the recordings to the CDX folder.
Sure.
And once there's a little bit more clarity how to get recordings automatically from Zoom to OCP Wiki, I'll do that. But right now, I don't know how to do that automatically, so I might have to do it by hand after every meeting.
Okay. Okay, yeah, it should be there somewhere. Yeah.
Right, which is my least preferred way, but
right. Yeah.
You see how we can do it.
Yeah. Maybe Anu might know the answer. Like he was talking about, there are some work groups they have already used the Read AI, which summarizes the meeting, and so maybe we should leverage some of those things for the future meetings.
Yeah, the meeting summaries I do get, and I don't know what to do with those. Isn't aren't those sent to the entire mailing list?
I don't know. Maybe the OCP team might have some mechanism, right? You can,
I was actually talking to Anu about this whole recording thing, and tomorrow 8 a.m. we are going to discuss it again.
Okay.
And see how that goes. We are trying to get organized a little bit better.
Right. Yeah. At least
I have to go, David. Bye.
Okay. Yeah, I think we're top of the hour. So Bala, I think that next week is also since we switched topic last week. I think next week is also a test.
Okay.
Test. I'm not sure if it's worth meeting 2 times in a row or you want to skip it. Either way, how about we keep the meeting for next week, and if there's nothing new, we'll just have a short meeting.
Yeah, I have enough action items. Like I have other, like I skipped some of my Siemens action items this week, like so because of the some training. So it will be best like if we can skip the next week, and then by the time it allows the team also to digest this information and come with some questions and feedbacks.
Yeah.
Right. And what are the things, additional things that they want to add it to the this one, like so. Myself and Vikas, we are meeting like we plan to meet every alternate weeks. Like, yeah. So to have more detailed discussions, and so there are a few action items that I took it from him from the other meeting also. Yeah.
Okay.
Yeah, maybe we can make 2 weeks from now. Like so that way, like we are not get used like where SAPI versus test.
2 weeks actually is I think because it takes time to do these things along with the regular work. So
Yeah.
yeah.
I understand. I'm in the same boat as you guys. Okay. Yeah, let's play it by ear. For now, tentatively we'll plan to speak next week if something comes up, or if someone wants to meet, we can still meet. We discuss that. Without maybe have a quick short meeting, get some inputs and to just complete.
Yep.
All right, guys. So for now, tentatively we'll have a short meeting next week. If not, I'll talk to you actually not in 3 weeks.
Okay.
Thank you.
Okay.
All right.
Yeah. Thank you, folks. Yeah. Okay.
All right. Have a good one.
Yeah.